Hey everyone, welcome to our 18th Python tutorial. And I think today what we're going to cover is going to be really interesting and exciting to most of you, but it's also going to be pretty challenging and a little difficult to understand. And today we're going to be covering the concept of Python recursion. So in the English language, recursion is roughly defined as a process of defining a problem or the solution to a problem in terms of a simpler version of itself. And some quick examples. I don't know if this is exactly right, but you could almost think of it like Inception, where we have a dream within a dream within a dream. So that's kind of what we're doing here, and a more formal way to describe it is that in programming, a defined or a recursive function, it's defined as a function calling itself within its definition. So it sounds super confusing, but it will make a lot more sense, or it might not make that much sense either, but it's important to see a visual example of what exactly recursion is doing. So you can see within the function that we've defined, we are simply calling it back. And you see this a lot with algorithms or with number sequences. So to start out, I'll go ahead and make a quick recursive function for you to look at. And before we start that, when working with recursive functions, it's really important to be wary of creating a function that will at least terminate, right? Because we don't want a function to go on forever and take up immense memory or processor power. So once again, I'll go into this and make a quick program for our recursive function that will just describe exactly what it does and how we can use them throughout our code. So let me get started. Right, so I've completed this quick example of a recursive function, but before I run this program, since we're working with factorials, it's important to get a quick look at what a factorial is and how it relates to our recursive function. And you need to see the recursion occur within that number sequence for you to officially make sense of this recursive function process that what we're doing. So I'm going to pull up a quick picture of a factorial so you guys get a quick understanding of how a recursive function comes into play. Right, so I pulled up a quick image of a factorial, and you can see right here we're taking 4 factorial, and what 4 factorial simply is 4 times 3 times 2 times 1. So that's a quick way to look at what exactly 4 factorial is. Another way to see it is that 4 factorial is simply 4 into 3 factorial, and 3 factorial is 3 into 2 factorial, and 2 into 1 factorial. So that's where that recursion comes into play. We're defining 4 factorial in terms of another factorial. So that's how we're going to see it in this program. So when I run this program, you can see we're saying if n is equal to 1, return 1. So that's what 1 factorial is equal to 1. And for all other scenarios, we're having a result, and we're saying a result is equal to our number n. So in this case, we're supplying 5. So it would be 5 into factorial of 4, because 5 minus 1. So now when we supply 4 in here, it's going to come in, go to if it's not equal to 1, so then once again it's going to come into here, and it becomes 4 into 3 factorial, and then 3 into 2 factorial, and then 2 into 1 factorial. So that's what the main change or shift in our program comes when it reaches 1 factorial. So when we come into 1 factorial, it's going to return 1. So when it comes back, it's going to be 2 into 1, and that's going to return 2 right here. And then you come all the way back. This requires a lot of imagination, but you have to go back to our 3 factorial where we had 3 into 2 factorial. And since we've determined 2 factorial to be 2, that becomes 3 into 2 is 6. You go back another level, that's 6 into 4, that's 24. And then you go back one more level, and you get 24 into 5, which will be 120. And that should be our result for our factorial. And you can see with all that mind-bending logic, we are returned with 120 as our result. So now I just want to take a second to talk about the advantages and disadvantages that come along with recursion, and I briefly talked about it right here, but let's just get more in depth. So advantages of recursion: we know that recursive functions make the code look very clean and elegant, and that's one major plus whenever you're trying to show and explain your code to others. Another advantage is that recursion breaks down a complex task into really simple sub-problems. And lastly, that sequence generation is much easier with recursion than using nested iteration. So this sequence generation, that's what we're going to be mostly using recursion for and that's just to make these long sequences or intricate algorithms using recursion. So now that we know the advantages, now we'll take a look at the disadvantages. And the disadvantage is that the logic behind recursion is really hard to follow through, especially when it gets more complex. And we saw a lot of that right here with a very simple program. And then next is that recursive calls are expensive, and by expensive they're inefficient. They take up a lot of memory and a lot of time, and you'll see that in one of the programs that we define next. And then lastly, it's that recursive functions are really hard to debug once you find an issue. So that's some quick advantages and disadvantages of recursion. So you see there are a lot of pros and cons, and most of the time the pros outweigh the cons, but in this case you have to be really selective with how and when you use recursive functions, because one mistake could really screw things over in terms of memory and time. So now that we got a quick rundown of how exactly a recursive function works, I'm going to give you guys some pretty tough challenges. And the first one is, let's try to make a Fibonacci sequence using a recursive function. And then the other one, which I found to be pretty tough and kind of mind-bending, was to make the Pascal's triangle using a recursive function. So I'll go ahead and pull up images of both of those and show you how exactly you can use recursion with those algorithms or sequences. So let me go ahead and pull up two quick images of the Fibonacci sequence and Pascal's triangle. Right, so here's a quick image of the Fibonacci sequence. And to get a quick understanding, you can see this 1, 1, 2, 3, 5, 8. And I'm sure you guys have heard of the Fibonacci sequence before. But the quick and interesting part is that within the Fibonacci sequence, you can see that we're adding the first two numbers to get the third number, and the second and third number to get the fourth number, and so on and so forth. So that's where the recursion is occurring. We're adding the first two numbers in order to get the next number. So that's mainly where your recursion is going to take place for your first challenge. And in the second challenge with the Pascal's triangle, this one I found to be a little bit more complex, but as you can see here, what we're doing is with our first, the recursion takes place past the third row. So with our third row, you can see for the middle value 2, we're adding up 1 and 1. And in the next row, for 3, we're adding up 1 and 2. And 2 and 1 give you 3. And for this last row, you can see 4, we have 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. So that's where the recursion is occurring within our Pascal's triangle as well. So now that you guys got a quick understanding of how the Fibonacci sequence and the Pascal's triangle are working with recursion, let's go ahead and try to do those pretty tough challenges. And I'll give you guys a lot of time, I won't give you guys a lot of time, but I suggest you pause the video, take as much time as you need. The real learning comes when you guys are struggling and working through the problems. So it can be done, it's not impossible, but it does take a little bit of mind bending and trying to wrap your head around the concepts. So I recommend you guys pause the video, take as much time as you need, go get a snack, do whatever, but try to get this done and then come back to me and I'll show you how I did it. And maybe my way was worse than yours, or maybe it was a little better, but I just want to show you guys how exactly recursion can be used for these more tougher algorithms and sequences. So go ahead and get started, pause me in place, and come back to me when you need my help. Okay, bye. So by now, I'm assuming you guys completed these recursion problems, and I know they were pretty challenging. And even if you didn't get them, the part where you try and figure things out is the most important part. So now that you've come back to me and unpaused me, I'm hoping, let's get into creating these recursive functions. So to start out, I will make my Fibonacci series recursive function. Let's begin. Alrighty, everyone. So I've completed this quick little program into function recursion for our Fibonacci sequence. So you can see it looks super tiny, but it is really kind of a monster when you think about it. So To start out, I simply am just using user input, and with our user input, it's inputting which term in the Fibonacci sequence that we want to acquire. And the main important part of this program really comes with these first 4 or so lines, and this is what makes sure our program does not run forever and take up a bunch of memory, and it eventually returns something. So obviously if I were to input 1, that would give us 0, and if I get 2 or 3, that's gonna, both of those are 1s in our Fibonacci sequence. So the real code comes after with our 4th term. So if I were to call the 4th number, right, if I were to use 4 as my input, it'd simply come here and then go to our else statement and return Fibonacci recursion of 3 plus 2. And that's how you get the value of 2 right here, because 3 and 2 both return 1. So once again, it looks like a really simple program, but hopefully you guys are able to understand that Fibonacci recursion is a little bit tough. So let me run this program, and let's say I put in term number 5. So we're getting the term 3, and let's go ahead and try to break that down once again. So if we input 5, it's going to come over here and ask to add 4 and 3. So with 4 and 3, we know 3 is 1, but 4, it's going to come back in here, and with 4, it's going to come down here and add 2 and 3. So sorry, 3 and 2. And 3 and 2 give us 1. So once this statement becomes 1, and this is 2 already. Sorry, this statement becomes 2, and this is 1. And then 2 and 1 get you 3 eventually. So once again, it's a little tough to wrap around, but it really was interesting and fun to build this Fibonacci recursion program, and I hope you guys also had a little bit of fun doing that. And now let's get into the much more challenging one, for me at least, and that was working with the Pascal's triangle. So let me go ahead and write this program, and then I'll break it down and show you guys what exactly I did to complete this problem. Okay, so this one is the really kind of challenging one to break down and sort of explain, but let's take a shot at it. So here I've defined our Pascal recursion function, and right away you can see what I'm trying to do is print out the whole row of the Pascal's triangle. So the first one is obviously 1, and the second one has 1, 1. So those are kind of similar to what we've done in our Fibonacci sequence, and even our factorial sequence, is that I'm setting some terms that I know are like definite terms that we can't really, that like are the start of our sequence, to sort of ensure that it doesn't make an infinite loop. So with, let's say I were to call the third number, what it's doing is, what I noticed with our Pascal triangles and with those lists, is that the first and the last number of each row is a 1. So what I'm really trying to do is identify the numbers in between those ones. So I've defined a list called the first term 1, and I will append all my other terms onto that right after. So I've set x to 0, and y I've set to n minus 2. And once again, that's because the 1 and the 1 I'm not trying to count, and I'm just setting that. So if it were 3, I'm really only trying to find one term in this case. So with that, we have while y is greater than 0, we are making a quick little while loop. And within that, this main chunk is stating that with our Pascal recursion, we're trying to access the first term of that list, or like one term, and then the term right after. So if I were to take 3, it would be y would give you 1, and x is 0 obviously, and the first term is 1. And then within that, while y is greater than 0, we're appending the first term, right, x is 0, the first term of the second list, and the last, or the second term of the second list. So it's going to add up 1 and 1 and give us that third term to append into our list. So I know that sounds really confusing, but hopefully when I run it, it will make a lot more sense. So I've run it with 5, and what 5 means is that it's going to come here with our, because it bypasses these two, it's going to come to our else, and it starts out with 1, and then what we're doing is 5 minus 2 is 3, so we're looking for the 3 terms in the middle in that 5th row. And with that, we're going to add the first term of the fourth row and the second term of the fourth row. And then we go through that, and then once we add the first and second, then we're adding the second and third, and then the third and the fourth row. I think that's how it works. So when I run it, that's what it's going to give us. So it's going to add 1 and 3, and then 3 and 3, and then 3 and 1, and give us these 3 terms. So I know it's really confusing and kind of hard to understand, but I hopefully function recursion was a little fun to you guys. Obviously it's a confusing topic, but once again I hope this gave you guys a quick understanding of how exactly we can use function recursion. And once again, as always, I will be linking my code into the description of the video below, so you guys can always save this program and try to break it down on your own. And here's just a quick little fun recursion meme. So I'll see you guys in the next tutorial, and I hope you had a lot of fun.